Good morning, one and all. Today I am starting Unit 2. Okay, Unit name is Substations and Distribution Feeders. Okay, in that Unit 2, we are having the two topics. That is, first one is the substations, next one is the distribution feeders. Okay, first of all, what is meant by the substations? Okay, the assemble of operators used to change the some characteristics. That is, for example, voltage or AC to DC or frequency, power factor, etc. of electrical supply is called as the substations. Okay, what is meant by substations? The substations are used to change the some characteristics like voltage changes by using step up or step down, and also AC to DC converters and frequency changes, power factor equipments, that all equipments are to be together in the substations. Okay, the substation plays an important role in the power systems. Okay, it plays an important role in the case of a power systems. Okay, it is placed in between the generating station to the consumers. Okay, the substations is placed in between the generating station to the consumers. Why? Because we are using the substations, the generating stations are placed at very far away to the consumers. Okay, that's why the substations will be placed near to the consumers for the continuity of the supply, and also for the change of the some characteristics of that voltages, currents, and also AC to DC and frequency and power factors. Okay, therefore the substation plays a very important role. The substation plays a very important role in the case of a generations, sorry, in the case of a power systems. Okay, there are two important ways for the classifications of substations, that is according to the service requirement, according to the constructional features. First of all, what is meant by substation? It is a assemble of various components. It is a assemble of various components. That means the assemble of operators used to change the some characteristics. Okay, the assemble of operators used to change the some characteristics like voltage, AC to DC, or frequency and power factor, etc. of electrical supply is called as the substations. Okay, so the substation plays a very major role in the case of a power systems. Okay, their substations is placed in between the generating stations to the consumers. Okay, in between the generating station to the consumers. Okay, there are different types of substations are used for the satisfaction of that consumers. Okay, classification of substations. Okay, there are mainly two classifications are there, that is according to the service requirements and according to the constructional features. Okay, there are several ways of classifying the substations. However, the two most important classifications are there. According to the first one is the service, according to the constructional features. According to the constructional features. First, according to the service. According to the service, what are the substations are there? Okay, that all will be discussed in the below. In that first one is the transformer substations, switching substations, power factor correction substations, frequency changes substations, converting substations, industrial substations. Okay, these are the various types of substations according to the requirement of the service. Okay, according to the requirement of the service, the substations are classified like this. Okay, in that first one is the transformer substations. Okay, in that transformer substations, we step up or step down the voltage levels, or we changes the voltage levels, or we changes the currents by using the current transformers and by using the potential transformers. Okay, those substations which changes the voltage levels of electric supplies. Okay, those substations which changes the voltage level of electric supplies are called as the transformer substations. Okay, are called as the transformer substations. Okay, these substations are used for step up or step down the voltage levels or the currents. Okay, this substations receives the power at some voltage and delivers it at some other voltages. Okay, depending upon the requirement of the consumers, those substations are used to step up or step down the voltages or also the currents. Okay, depending upon the consumer's requirements, this type of substations will be operated for step up or step down the voltage levels. Okay, obviously the transformer will be main component in such substations. Okay, most of the substations in the power systems are switching substations. Okay, those substations do not change the voltage levels. Okay, in the transformer substations we are changing that voltage levels or we are changing that current levels. Okay, these substations are commonly used. Okay, but in the case of the switching substations, there is no change of the voltage levels. Okay, that is the incoming and outgoing lines have the same voltages. Okay, that is the incoming and outgoing having the same voltage levels. Okay, however, they simplify perform the switching operations. Okay, it will be used only for the on and off that load only. Okay, it will be used only for the on and off that powers. Okay, it is called as the switching substations. Okay, these substations not change the any voltages or the currents. Okay, it will be used only for the on and off that loads only. Okay, on and off that loads only. Okay, next type of substation is the power factor correction substations. Okay, these substations are very important substations for improvement or reducing that power factors. Okay, depending upon the incoming line. Okay, those substations which provides those substations which improves the power factor of the systems are called as the power factor correction substations. Okay, are called as the power factor correction substations. Okay, those substations which improve the power factor of the systems, which improves the power factor of the systems are called power factor correction substations. Okay, such substations are generally located at the receiving end of the transmission lines. Okay, this type of substations are placed at the receiving end of the lines. Okay, these substations are placed at the receiving end of the lines. Okay, these substations generally use the synchronous condenser at the power factor improvement equipments. Okay, these substations generally the synchronous condenser at the power factor equipments. The power factor equipments. Okay, next one is the frequency changer substations. Okay, next one is the frequency changer substations. Okay, those substations which changes the supply frequencies. Okay, these substations are used to change the supply frequencies. Okay, are called as the frequency changer substations. Okay, such a frequency change may be required for industrial utilizations, not for the any other applications. This type of substations are not useful for the other applications. It will be used only for the industrial applications. Okay, in that industrial area, industries, some industries we are requiring the variations in that supply frequency. Okay, that's why in that case only we are using the frequency changer substations. Okay, those substations which changes the supply frequency. Okay, those substations which changes the supply frequency is called as the frequency changes substations. Okay, such frequency change may be required for industrial utilizations, may be required for the industrial utilizations. Okay, this type of substations are to be used for in the case of industrial applications. Okay, next one is the converting substations. Okay, these types of substations are used to convert the AC to DC powers. Okay, is called as the converting substations. Okay, these substations receives the AC power and convert it to the DC power. Okay, that AC power is converted into the DC power with a suitable apparatus to the supply for such purpose as a tractions, electroplatings, electric weldings, etc. Okay, in that applications we are converting the AC to DC. Okay, in that applications we are converting the AC to DC. Okay, next one is the industrial substations. Okay, those substations which supply power to the individual industries. Okay, those substations which supplies power to the various industries. Okay, this will be used only for that industrial purposes. Okay, these are the according to the service requirements. The substations are classified into transformer substations, switching transformer substations is used for the step up or step down the voltage levels. Okay, switching substations are used only for the on and off that operators. Next, power factor substations are used for improving the power factor for the receiving end of that transmission lines. Next one is the frequency changes substations are used to change the supply frequencies that will be used only for the industrial areas. Next, converting substations. Okay, this type of substations are used to converting AC to DC power. Okay, this type of substations are used only for the converting AC to DC power. Okay, this substation receives the AC power and delivering and converting into the DC power. Okay, these type of substations are used for in the case of a traction purpose and electroplatings and welding purposes. Next, industrial substations. Particular industry taking the particular substations, individual substations are placed for particular industries. For particular industries. Okay, these are the various classifications according to the service requirement. Next one is the according to the constructional futures. Okay, next one is the according to the constructional futures. Okay, according to the constructional futures, the substations have many components. Okay, the substations have many components like switches, fuses, circuit breakers, isolators. Okay, these are all the various components that will be there in the substations. Okay, a substation has many components which must have housed properly to ensure the continuous and reliable services. For the continuity and the reliability of that operations, we are using the various equipments or the various protective devices like circuit breakers, fuses, switches, isolators, lightning arresters, etc. are be used. Okay, according to the constructional futures, these substations are classified into indoor substations, outdoor substations, pole underground substations, pole mounted substations. Okay, underground substations, pole mounted substations. Okay, first one, indoor substations. Indoor means we are designing the one room. In that room only all the equipments are to be installed here, and then we convert voltage levels are the we convert frequency levels. Okay, for voltages up to 11 kilovolts, the equipments of the substations. Okay, the equipment of the substations is installed indoor because of economical considerations. Okay, because of the economical considerations, This type of indoor substations are used. Okay, however, when the atmosphere is polluted with impurities, these substations can be erected for voltages up to 66 kilovolts. Okay, where the place requirements is very costly. In that case, we are selecting the indoor substations. Okay, but it will be suitable only for up to 11 kilovolts. For maximum, we are using up to 66 kilovolts. Next one is the outdoor substations. For voltage beyond 66 kilovolts, equipment is invariable and constant. Okay, it will be installed outdoor only. Okay, it is because of such voltages, the clearance between the conductors and the space requirements for the switches, circuit breakers and other equipments. Okay, for above 66 kilovolts, that equipments are installed only outdoor only. Why? Because means such types of voltages and the clearance between the conductors is very major important consideration, and the space requirement for that switches, circuit breakers and other all the equipments is the one of the major important consideration in for above 66 kilovolts. Okay, so greater that it is not economical to install the equipments indoors. Okay, why? Because we require some space between the switches, fuses, circuit breakers and transformers. Okay, that's why it is not economical for the indoor applications. So for that reason, above 66 kilovolts, we are selecting only the outdoor substations. Okay, for the clearance between the conductors. Okay, for the clearance between the conductors, we are selecting only the outdoor substations. Next one is the underground substations. Okay, next one is the underground substations. Okay, in thickly populated area, the substation available for the equipments and building is limited. Okay, in the thickly populated area, the space requirement is very major important consideration. Okay, in that situation, we are selecting the underground substations. Under such situation, the substation is created underground only. Okay, in thickly populated area, the space available for the equipments and buildings is limited. Okay, and the cost of that land is very high. Land is also very high. Okay, under that situations, the substation is created underground. Okay, under that conditions, the substation is placed in the underground. Okay, next last one is the pole mounted substation. Okay, the pole mounted substation. Okay, this is an outdoor substation. Okay, there is no room in that pole, only it is the outdoor substation with equipment installed overhead on H pole or the 4-pole structure. Okay, that equipments are installed on the H pole or the 4-pole structure. Okay, it is the cheapest form of substations. Okay, it is the cheapest form of substations for voltages not exceeding 11 kilovolts. Okay, for the voltages not exceeding 11 kilovolts. Okay, therefore, electrical power is almost distributed in the localities through that substations. Only. Okay, in the pole mounted substations, it is the very simple and cheap for the voltages not exceeding 11 to 33 kilovolts. Okay, beyond that voltages, the pole mounted substations is not economical. Okay, beyond that voltage levels, the pole mounted substation is not economical. Okay, electric power is almost distributed in the localities through the such substations. For more, and the poles mounted substations have only suitable up to 11 kilovolts or up to 33 kilovolts, Okay, these are the various types of substations that will be classified according to that service, according to the constructional requirements. Okay, in that we are having the some of the advantages and disadvantages are there for that substations. In that first one, it's the indoor substations. Okay, what are the advantages are there for that indoor substations? There is no risk of the weather conditions. Okay, there is no formation of that rust because the all equipments will be placed in that indoor room only. Okay, that's why there is no risk for that weather conditions and maintenance of that operators. Okay, there is no need for the installing any protective devices for protecting the equipments against the lightning surges and rapid temperature changes. Okay, next, what are the disadvantages are there in the case of a indoor substations? Means that it is difficult to locate the fault. Okay, where the fault will be obtained, that will be find out is very difficult consideration. Okay, the possibility of the fault occurrence is more. Okay, why? Because the possibility of the fault occurrence is more means that there is no space in between the one equipment to the another equipment. There is no clearance between the equipments. Okay, that's why the fault obtained is very quickly. These are the some of the disadvantages are there in the case of a indoor substations. Next, outdoor substations, the advantages are the location of the fault is very easily. Why? Because identification of that fault is very easily means that there is a space in between the conductor to conductor. Okay, that's why we are easily identify the faults. Okay, future extension of the outdoor substation is very easy. Okay, in the indoor substation, the future extension is difficult and costly. Okay, that's why in the case of a outdoor substations, the future extension is also very easy. Next, coming to the disadvantages in the case of a outdoor substations, that is the area required for that outdoor substation is more. Why? Because the area required for that outdoor substation is more means that we are requiring the space between the conductor to conductor for the clearance. Okay, that's why the area required for that substation is more. Okay, therefore the investment for that area is increases. The investment cost for that area is increases. Okay, it is easily affected by the environmental conditions. Okay, in the indoor substations, there is no risk for the weather conditions or the changing in the weather. Okay, but in the outdoor substations, there is a it is easily affected by the environmental conditions. Therefore, the equipments will be damaged with the environment, that is the rust, formation of that rust and also etc. Okay, next one is the what is the advantages are there in the case of a underground substations. Okay, underground means the in the below the ground level we are designing the one room. Okay, we are constructing the one room. Okay, it is only suitable for the safety of the public service, public safety. Okay, it is suitable for the public safety. Okay, this type of substations are very much preferred where the cost of the land is high. Okay, this type of substations is only preferred when the cost of the land is high, or where the land is not available, or where the land is not available. In that case only we are using the underground substations. Next, what are the disadvantages are there in the case of a underground substations? Okay, the construction is difficult and fire hazards is also possible. The construction is difficult. Why? Because the construction is difficult. Under the ground levels, we are designing the specified place or the specified room. Okay, that's why the construction is very difficult for the design of that underground cables. And the fire hazards is also possible. Why? Because means the continuous checkup is not obtained in the case of your underground substations. Okay, that's why the fire hazards are also possible. Okay, that's why that is the main reason for the formation of that fire hazards. Next, what are the advantages and disadvantages are there in the case of a pole mounted substations? Okay, in the pole mounted substations, the advantages are it requires very less space. Okay, why? Because it requires very less space means that in that pole only we are constructing or we are installing the various equipments. Okay, that's why we requires the very less space. Okay, it is very cheap and simple in construction. Okay, it is very cheap and simple in constructions. Okay, next coming to the disadvantages. Okay, what are the disadvantages are there in the case of a pole mounted substations? Okay, it is affected by the environmental conditions. Why? Because it is affected on the top of that pole. Okay, we are installing the various equipments. Okay, that's why it will be easily affected by the environmental conditions. Okay, it is only suitable for the distributing the power to the local areas, that is very high capacity substations cannot be installed on the pole. Only it will be installed up to below the 11 kilovolts. Okay, these are the various types or various classifications of substations. Next, what are the equipments are there in the case of a substations? What are the equipments are there in the case of a substations? First one is the lightning arresters. Why? Because we are using the lightning arresters. Okay, by using that lightning arrestor, we give the protection from the lightning strokes that will be obtained, and also it gives the protection for that lightnings. Okay, the lightning arresters are the instruments that are used in the incoming lines. Okay, it's so that to prevent the high voltage entering the main stations. Okay, so that we are preventing the high voltages that will be entered due to the lightning strokes. Okay, that will be prevented by using these arresters. Okay, this high voltages is very dangerous to the instruments used in the substations. Okay, it is very dangerous to the instruments will be used in the substations. Even the instruments are very costly. Okay, the instruments are very costly. That's why we are using the lightning arresters. Okay, so to prevent any damage, lightning arresters are used. Okay, the lightning arrestor do not let the lightnings to fall on the station. If some lightning occurs, the arrestor pull the lightning and grounding it to the earth. Okay, by using these lightning arresters, that lightning is to be grounded and to the earth. Okay, in any substations, the main important is of protection, which is firstly done by these lightning arresters. Okay, these lightning arresters are grounded to earth. Okay, so that it can be pull the lightnings to the ground. Okay, by using these lightning arresters, that lightning will be pulled down to the ground. Okay, the lightning arresters work with an angle of 30 to 45 degrees. Okay, making a cone. Okay, this is the use of the lightning arresters in the case of a substations. Next, capacitor voltage transformers. Okay, these voltage transformers are used to step up or step down the voltage levels. Okay, the capacitor voltage transformer is a transformer used in the power systems to step down extra high voltage signals and provide low voltage signals. Okay, this will be used to step down the voltages. Okay, in its most basic form of the device consisting of a 3 parts, 2 capacitors across which the voltage signals is split. Okay, and inductive elements used to tune the device. The supply frequencies. Okay, this is the use of a capacitor voltage transformers. Mainly the voltage transformer are used to step down the voltage levels. Okay, these are the wave trap. These are the wave traps, and these are the capacitive voltage transformers. First, what is meant by the wave trap? Okay, wave traps are used in the substations using power line carrier communications, PLCC. Okay, power line carrier communications is used to transmit the communications and control information. Transmit the communications and control the informations at a high frequencies over the power lines. Okay, this is the use of the wave trap. Okay, these wave traps are used to transmit the communication and control the information at a high frequencies over the power lines. High frequencies over the power lines. Okay, this is the use of a wave trap. Okay, the wave traps is like this. PLCC, power limit control and communicate the and control the informations at a high frequencies. Okay, next, instrumentation transformers. This instrumentation transformers, the measuring instruments and the protective devices are designed for the low voltages, that is current above 5 amperes. Therefore, difficulties is overcome by installing the instrumentation transformers on the power lines. Okay, the function of this instrumentation transformer is to transfer the voltages or currents. Okay, this will be used for transferring that voltages or the currents. For transferring the voltages or the currents. Next, current transformers, potential transformers. Current transformer are used to step up or step down the current levels, and potential transformers are used to step up or step down the voltage levels. Okay, next, bus bars. Bus bars is the line which the incoming line get into the instruments for the step up or step down. Okay, the bus bars are used to incoming and the outgoing lines. Okay, these are the double lines. One is the entering and other one is the returning path. Okay, there may be double lines in the bus, so if any faults are occur in the one of that line, and other bus will be used as the both for the entering and the returning purpose. Okay, both works will be shared by the one bus bar only. One bus bars only. Okay, by using the size of that bus bar will be decided by the rating of the current. Okay, that will be depended on the size. Okay, next, circuit breakers. We are well known about that circuit breakers. It will be used to break or make the circuit for normal and abnormal conditions. Okay, we are having the different types of circuit breakers are there. Oil circuit breakers, Sf6 circuit breakers, vacuum circuit breakers. Okay, these are the different types of circuit breakers. Next one is the power transformers. Power transformers are used to step up or step down the voltage levels. Next one is the isolators. Isolators are used to isolate the faulted portion for in the case of a transmission lines or in the case of a distribution systems. Okay, these isolators are used to protect the transformers and the other instruments. These isolators isolate the extra voltages to the ground, and thus an extra voltages cannot enter into the line. Okay, by using that isolators, the extra voltages does not enter to the line. Okay, this isolators is used after the bus also for the protections. Next one is the Protecto Release. Okay, the Protecto Relays are used to detect the defective lines or the operators and to initiate the operation of that circuit interrupting devices to isolate the defective equipments. Okay, these relays are classified into overcurrent relays, distance relays, differential relays, and directional relays. Okay, the main purpose of that relay is to give the indication for that circuit breaker or give the alarm signal to the circuit breakers. Okay, when the overcurrents are obtained, in that case, the overcurrent relay will be operated. And like that, the distance relay will be operated when depending upon the distance between that faults. Next, DC power supply are the DC battery chargers. Okay, these are all the various equipments in the case of a substations. Okay, this is the potential transformers. This will be used for step up or step down the voltage levels. This type of potential transformers are used to step up or step down the voltage levels. And this is the current transformers. And these are the current transformers. These transformers are used to step up or step down the current levels. Next, these are the circuit breakers, oil circuit breakers, and this is a practical view of that oil circuit breakers. Okay, this is the practical view of that oil circuit breakers. Next, these are the Sf6 circuit breakers. This is the practical view of a Sf6 circuit breakers. Next, this is the isolators. Okay, that isolators are used to isolate the faulted portions. Okay, this is the practical view of that isolators. Okay, these are the various equipments that will be placed in the case of a substations. First of all, what is meant by substations? It is a combination of the various equipments. Okay, the ensemble of operators. Okay, these are all the various operators, that is CTs, PTs, instrument transformers, wave trappers, voltage transformers, capacitors, transformers, lightning arresters. Okay, these are all the various operators that will be assembled in that substations. Okay, these equipments are used to changes the voltage levels, are converting the AC to DC, are increasing the or decreasing the frequency levels, and also the power factors. Okay, it is called as the substations. Okay, these substations are plays very major role in the case of a power systems. In the case of a power systems. Okay, this will be placed in between the generating station to the consumers. Okay, it will be very near to the consumers. Okay, the substations will be located near to the consumers. Okay, these are the various classifications and the various equipments that will be used in the substations. Okay, these are the classifications of the substations, and this is the various equipments that will be used in that substations. Okay, in the next class we are discussing about the what is the location of the substations, how we will locate the substations. Okay, that will be discussed in the next class. And the rating of the distribution substations, how we were giving the rating for that substations. Okay, that will be discussed in the next class. Okay, these are the some of the equipments that will be used in the substations: wave trappers, capacitors, current